Welcome, everyone. My name is KC Wang. I'm a co-PI on the Fabric project. Thanks, everyone, for joining us today for our Fabric 101 Hello Fabric webinar series. Today, I'll be led by Komal Thareja. Next slide, please. Before we begin, I'll just share a few housekeeping items. The webinar will include a live question and answer Q&A session right following the presentation. And you should be able to find a Q&A box at the bottom of your screen. That's where you can type in your question anytime, and we will answer it during the Q&A. Please note that the chat feature has been disabled, so just use a Q&A. At the end, the webinar will be recorded and it will be shared with all of you. Next slide, please. Today, we're joined by our presenter, Komal Thareja. Komal is a really significant member on the Fabric team. Komal holds a significant role as the lead software architect and developer across multiple projects supported by the U.S. National Science Foundation, including Fabric. As a software engineer at Renzi, she brings her expertise in database applications, cloud orchestration, infrastructure as a service, distributed systems, and scalable computing. Komal is not only instrumental in shaping the control software for next-generation networks and experimental testbeds like Fabric, but she also plays a crucial role as a key contributor to the Jupyter examples used for interacting with Fabric, as well as the user-facing library called FabLib. Prior to her current endeavors, she amassed extensive corporate experience. She focused on architecting and implementing applications with the mobile communications industry. So now I will welcome Komal to start her presentation.
Thank you, Casey. Hello, everyone. Let's learn a little bit more about Fabric. What is Fabric? Fabric is a NSF mid-scale research infrastructure that empowers researchers to securely prototype and validate their disruptive designs, network design, in an environment that closely emulates the production environment that is used by computer science today. Fabric can be thought of as a scientific instrument or a lab that enables experimentation with new paradigms for distributed applications and internet protocols that run across and within the network. How does Fabric look like? This slide shows Fabric's footprint, which spreads across 33 locations, which are interconnected by 100 Gbps links shown in blue here. And we also have terabit core highlighted in yellow here. Each location here, represented by these blue dots, can be thought of as a small cloud where experimenters can deploy their private clusters, private routers, switches, connect them to traditional compute and storage, and also have advanced accelerators like GPUs, FPGAs, programmable NICs. These user-controlled in-network computational resources are connected with networked circuits between the sites and are dedicated to the user. This gives the user a good big playground to test their experiments, do the research, and validate their experiment before they can deploy them into the production environment. Fabric also partners with AL2S Internet 2 to connect Fabric experiments with the public cloud like AWS, Google Cloud, Azure. In addition to the Fabric's presence in US, we also have presence in Europe, University of Bristol, University of Amsterdam, CERN. We also have a site at University of Tokyo. All this is also funded by a separate NSF grant called FAB, which is a short for Fabric Across Borders. So what does Fabric bring to the table? As I've already pointed out, Fabric connects many of the facilities and services we all use for scientific computing with user programmable networks. But this is an evolution. A foundational tool of scientific computing is connecting these facilities across the dedicated networks. Today's scientific computing is totally dependent on these high performance networks for traditional tasks such as data transfer and staging, controlling the remote devices like a cryo EM in a lab or telescopes. At the same time, it is also becoming more common for scientific users to integrate multiple facilities into um, their experiment, into a single experiment, such as advanced computational workflows that involve several stages that ingest data, process data, and distributed data. Sometimes these workflows control remote instruments I already mentioned. Mm, So Fabric gives you a way wherein you can connect your experiment across facilities as well. I'll talk a little bit more about that in the subsequent slides. What are the current resources and tools? Much of what scientific computing users can accomplish today is a result of the powerful resource and tools which are available to us that have been developed and deployed uh, over many decades. These include traditional compute centers with large clusters, advanced workload managers. More modern resources you can think of are something like data transfer service such as Globus, opportunities enabled by new underlying technologies. In addition, like cloud is fairly new, and it has transformed the way you deploy your services today. Um, there are barely any, even if you talk about in corporate sector, everybody is trying to deploy their services on the cloud. There is no on-premise anymore left. We have science DMZs, which have greatly increased the speed and efficiency of data being transferred to or from campuses, bringing the performance of many campuses on par with the dedicated DTNs at computing centers. And Internet 2's AL2S Cloud Connect system, which has enabled on-demand, high bandwidth connections between campuses, data centers, and public clouds. All of these tools are great, but the reality of the internet is the routers are still only designed to transfer packets, packet in, packet out. We're not doing anything intelligent at the routers still. And this hasn't changed in decades. Applications are still limited to running at the edge, and all the optimization we are trying to achieve are still localized to edge. There's a growing emphasis on using the edge cloud paradigm where applications run across facilities and platforms. In this, HPC centers can be thought of as a cloud. Currently, end-to-end network performance is achieved through like layer 2 L2S, optimized DTNs, or science DMZs. But with a growing footprint of distributed data, requiring us to transfer data between across facilities, there's a need for us to do processing in the network. Another way to view this is that there are processing capabilities in the instruments, data centers, and the public clouds, but we are not using them yet. So this is a limitation which is imposed on all of us. And Fabric is trying to address this. Let's find out how. So there's this quote that Henry Ford probably wouldn't have said, but the sentiment is useful. While designing his cars, he said, if I'd asked people what they wanted, they would have said faster horses. But imagine if he was designing the internet with routers that only forward packets. It's easy to think that they would have all said all they wanted is faster networks. We are at inflection point similar to 1990s when internet was just becoming popular and Tim Berners created a new layer, HTTP, making it super simple to share data via the web. Nobody thought at that time how HTTP would be used. We use practically HTTP almost everywhere these days. We think that smart programmable cyber infrastructure connecting to scientific compute facilities public clouds, campuses, and instruments is an opportunity to rethink how the core network is used and develop new layers of software to make it possible to deploy applications across edge core cloud, or rather, edge fabric cloud. Towards this goal, let's find out what Fabric offers, what Fabric brings to the table. Fabric allows you to run applications anywhere, edge, cloud, or in places where the routers and switches are found today. This enables in-network processing and intelligent caching of data, distributed AI, and many other uses that are difficult to predict at this time, but soon might be commonplace. Fabric scales both in geographical size and performance capabilities. I already mentioned before in the slide where I showed the footprint of Fabric, there are like 33 sites with 100 Gbps links. And then we also have 1.2 terabit links as well. Fabric also offers services which allows you to connect Fabric to other facilities, such as Chameleon Cloud, Open Cloud Testbed, Cloud Lab. You can also connect to public clouds such as AWS, Google, Azure. So what is Fabric trying to achieve? Fabric is not in trying to replace your existing infrastructure. For example, we would still use, as I already indicated, we are still using L2S to connect, or AWS Direct Connection to connect Fabric to public cloud. Instead, Fabric is meant to be a powerful sandbox for experimentation that minimizes security risks and disruptions to your production environment. It is infrastructure as a software, which enables rapid test cycles with automated redesign. The sandbox power comes from real high performance, low level dedicated network connections across the wide area, combined with advanced in network compute, storage, and accelerators such as GPUs, FPGAs, programmable NICs, and switches. Further, it enables realistic experimentation by connecting the user's existing facilities with smart programmable core network across a wide area. So if you already have an experiment running on Chameleon and you want to run part of it on Fabric, we have a way for you. Bring your experiment here. You can connect your Chameleon part of the experiment with Fabric part of it as well. Another thing I'd like to point is Fabric is not replacing your existing tools. For example, it's not going to replace Globus for data transfer or your Pegasus workflow management system. Rather, it is giving you an opportunity to explore how these two existing tools can be implemented or reinvented in a new ways to use them. We find new ways to use these tools using Fabric. It will also allow for invention of new tools and applications that are deployed in and across the network core. These innovations will be incredible to predict, but will be fascinating to watch develop. What's Fabric? So how Fabric is impacting scientific computing? Fabric makes it possible to experiment with advanced programmable compute and storage in the network core at scale with edge facilities that you already use. This will empower academic researchers to invent the next generation of in-network applications and tools. So how does the next gen cyber infrastructure look like? Next generation scientific computing will be unbound from any specific compute resources. Applications will natively run across platforms and domains while including smart in-network processing and computing. We expect current and future Fabric users like you to produce the next generation of these new novel in-network applications before these applications are commonly available on research and education networks. Beyond producing experimental tools and applications, Fabric can be used for validation of full-scale prototypes that use disruptive technologies. Many times, risky and expensive ideas never see the light of the day. This is especially true if the idea requires disruptive changes to the core of the wide area network. Fabric enables deployment of such prototypes at scale in a secure sandbox environment while connected to the real production facilities. So, this measured validation of these prototypes can be used to justify the effort and money to be spent on transitioning these prototypes to production environments. So, in addition to providing so many features on um, sandboxing your novel experiments, the Fabric also offers the ability to operate and take full advantage of um, bandwidth wide area networks is a sought after yet rare skill in academic environments. Many people on this call have these skills, but it is difficult to acquire these skills from a book or a virtualized environment. Fabric provides a platform for deploying like custom WAN topologies connected to the real end systems, including shared programmable systems such as Chameleon or Cloud Lab. Fabric also provides a unique opportunity to learn and operate deeply programmable networks. So this not only enables us to do novel experiments, it is also allowing us to provide hands-on training for the next generation of CI engineers with minimal impact to production networks. Further, like Fabric all allows to create like shareable, reproducible, and publishable experiment artifacts. We use Jupyter Hub, Jupyter notebooks to create your experiments. You can, once you've created an experiment with Jupyter Notebook, it's easy to share with others and they can reproduce your results. Let's talk a little bit more about design and architecture of Fabric. How does a typical site on Fabric look like? I'm bringing back this slide, which shows Fabric's footprint on the network. You can clearly tell the focus is on the networking here. Before I go ahead and talk more about it, every blue dot here represents a site, and that is what I'm going to talk about now. What kind of hardware does each site have? Each site has a rack of high performance servers um, with lots of cores, a lot of RAM. We also have network and compute accelerators such as GPUs, FPGAs, a lot of storage in the form of NVMe drives or rotating storage. Then we are also working on deploying the P4 switches so people can program those switches to run their new P4 experiments. A single node in this rack of servers is what we call a Fabric hank. A single node on Fabric has, as I earlier mentioned, is connected to the management switch. That is how it is accessible by the users. Management network is the network which provides access, public access to the resources users request. And then we also have it connected to the data plane network. That is where this is the network where you would be doing your experimentation. We have some of these nodes have P4s, and then compute and network accelerators such as GPUs, FPGAs, NVMe drives, and then we also have smart NICs available on these workers too. Let's talk a little bit more about the features and the capabilities offered by Fabric. We offer several different kinds of network services to connect your resources as part of your experiment. For example, you could have an experiment with several VMs. Some of the VMs could be connected on layer 2 with local bridges or wide area connections, and while others could be connected on a layer 3 network with which we call as Fabnet service, which is could be either IPv4 or IPv6. We do offer dedicated smart NICs, ConnectX 5 with 25 Gbps and ConnectX 6 with capability capability of 100 Gbps links. There is storage available as well in the form of local disk, NVMe drives. We also allow you to create request persistent storage across different sites so that you can collect the data as part of your experiment and save that there. Compute accelerators in the form of GPAs, network accelerators in the form of FPGAs, and then we also have the capability to connect your experiment across testbeds, across public clouds. A typical experiment on Fabric would look like you would have some resources on, let's say, Chameleon, or some resources on a public cloud, such as Amazon or Azure, and some resources you have at your institution, and while other resources are sitting in Fabric. You could connect all these resources together using Fabric's capabilities and run your experiment. So it not only provides you in-network processing and caching, it is giving you a very realistic experiment wherein your resources are distributed across several testbeds and public clouds. Let me show you a little of a few of our example use cases, which show how Fabric has been used extensively to do really cool things. This is the first example. Here, there's Rutgers University has a cryo-EM. Cryo-EM is a microscope which works at a really cold temperatures. So as part of this experiment, what they're trying to do is they are trying to collect data from the measurements taken by the cryo-EM, and they have developed a platform called Cloudlet. They use this platform, which talks to the cryo-EM, to transfer the data from the cryo-EM to the Pittsburgh Computing Center, wherein scientists can use that data for further analysis. So what they've done is they have deployed their Cloudlet on Fabric and connected that Cloudlet to the actual remote device in the Rutgers lab, and are able to transfer the data to the Pittsburgh Computing Center. This slide shows a typical example how they deployed this, how their deployment began with before they could actually transfer the data to the Pittsburgh Computing Center. So they had a few resources deployed at Chameleon, they had few resources deployed at Open Cloud Testbed, and then a couple of resources on Fabric. The host on Fabric here is connected to the cryo-EM at Rutgers. So using Fabric and its network capabilities, as well as the APIs we exposed, they could span this experiment from their lab to Fabric to Chameleon and Open Cloud Testbed. So this is a typical federated experiment. And all this could be done really easily. I'll talk about that in a little bit. Another example is similar to cryo-EM is CMB S4. In this experiment, they have 12 telescopes on the top of a mountain in Chile, surveying the sky. And what they typically do is they transfer the data from the telescopes to NCSA, where it's processed, and then the data is then sent to various other scientists for running their other applications on using that data. We don't have access to the telescopes in Chile yet. So what they did was to run this experiment on Fabric. They came up with a synthetic telescope at FIU, Florida University, and then they launched their experiment on Fabric, mimicking the communication between the real telescopes. And they were able to use the network accelerators and GPU accelerators in Fabric to do the in-network data processing, and then send the data to the research scientists who were using that data. Another really cool example of how Fabric is used is the Service X. Um, this is um, this is a part of a project called LHC Atlas at CERN. Um, in Service X, what they're trying to do is deploying data networking on Fabric. Name data networking works typically different than how we think of networks. When you think of networks, the first thing that comes to mind is IP addresses. Uh, Typical internet doesn't work without any IP address. But in the name data networking, there are no IP addresses. That they just label the data with a name, and when they want to fetch the data, they tell the network, "Get me that data." The network is intelligent enough to figure out where that data resides and brings the data back. Um, I know this sounds like a very easy explanation to a very complicated thing, but that's all I know. Maybe you can reach out to those people to learn more about how NDN works. But how they have done, and since I said NDN doesn't need IP addresses, they cannot deploy this experiment today natively on the internet. What they have been doing is using tunneling to deploy this experiment on the internet. But with Fabric, they can deploy this net experiment on Fabric natively without worrying about the tunnels. So this experiment was not natively possible on internet, and they could deploy on Fabric easily. This is another example of an experiment which is being conducted by Mike Zink, who is the PI for this project from University of Amherst, wherein um, they are they have drones collecting the data and transferring the data from cell towers to the nodes on the cloud, which is like Chameleon. They have few nodes on Fabric, which are also doing the processing of the data collected from the drones. And based on that data, they're taking decisions. They are using Pegasus workflow management system to run this entire workflow and taking decisions based on the data captured by the drones. So you can see how Fabric is being used in really cool ways. Now I'm going to talk about how, as a user for the first time, how you can use Fabric. We have an upcoming maintenance on Fabric starting tomorrow. So I have recorded this piece of the webinar, and I'm going to play the recording here. Fabric has three ways to interact with it. Portal, which allows you to create small topologies. Jupyter Hub notebooks, that not only allows you to create topologies, but you can run experiments with the notebooks. And the API libraries, which allows you to create topologies and run experiments from your laptop or desktop. We recommend that you start with the Jupyter Hub notebooks, and you can then switch to using API libraries as you become more aware of the various capabilities of Fabric. Everything continues to be in active development. We keep adding infrastructure, we keep improving all of the software. The infrastructure gets added as it becomes available. And for the software releases, we do have a cadence of 3 to 4 months between the releases. We shoot for achieving backward compatibility, but it's not always assured. Getting in. Everything in Fabric is tied to your institutional identity. Portal, Jupyter Hub, the use of APIs, all use CI logon to authenticate your institutional login. We do allow Google ID, but we prefer you use your institutional login. Again, GitHub ID is also possible, but we would require you to discuss with it beforehand. We recommend that you do not use Orchid. It is usually the first option you see on the screen when you log on with the CI logon. Before you can do anything on Fabric, you must enroll via the portal. Let's go and see how the portal looks like and follow through the sign up. This is how the portal looks like. It's your entryway into Fabric. So let us see. Let's sign up and let's follow through the steps as they show up on the sign up process. Before we go ahead, I would recommend that you make yourself familiar with the acceptable use policy. Now let's click on proceed to see a log on to sign up with Fabric. You choose your institutional ID here. As you can see, ORCID shows up at the top. Let's not use ORCID. Let's just use your institutional login. You see an error for me because I'm already signed up with Fabric. But for you, I would recommend that as a new user, just follow through the steps of the sign up and complete your registration with Fabric. Once the sign up has been completed, you would receive an email. Sometimes that email goes in the junk box or the spam folder. Please check there as well. That email contains a link which is active for 24 hours. So we recommend that once you receive that email, use that link to log on to the portal back within 24 hours. After you've completed the enrollment, you can now log into the portal. So let me go back and log into the portal here. Okay, now that this is the view you see when you're logged in, I do want to talk a little bit about this maintenance notice you see on the top. We have an upcoming maintenance coming up starting tomorrow. The testbed wouldn't be available for a week. We are upgrading our software, but the testbed would be back the next week, and you can always use and try to sign up with Fabric. Let's go back and learn a little bit more about projects. What are projects? Project is a group of experimenters with same permissions. Projects can be created by a project lead. Project lead who created the project can add project owners, and project owners can add or remove project members. Each project has a specific set of permissions by default. These permissions basically allow you to create only small VMs on a single site, and everything else requires you to request additional privileges. These permissions basically give you permissions to use specific Fabric capabilities, such as specific components, specific network capabilities. Let's go ahead and try and create a simple project. Let's click on the experiment tab. By default, it brings me to a page which lists all the projects I'm part of. Let's click on create project. Specify a meaningful name, specify a meaningful description, and click on create. You'll see this notice on the top, and then once the project is created, you'll be notified. So now the project has been created. As you can see, since I created the project, I'm also a project owner, but I can definitely add members as well. You can, as a project lead, I can also add project owners, and the project owners themselves can also add project members. I am going to use a Fabric tutorial project as an example to demonstrate what we are going to use. So this is a Fabric tutorial project. You're part as a user who signed up for this tutorial, you're part of this project. As you can see, this project has information about the project ID, the project permissions. It has an expiration date. This project ID, I'm trying to highlight this project ID because this is something we would use a little bit later. So every project has a unique ID called project ID. This will come in handy in a bit. And as I earlier mentioned, that each project has a set of privileges associated with it. For example, this tutorial project has these permissions. You can use these components. You can create VMs. You can use these facility ports. You can create VMs across multiple sites because we have this permission available here. Let's go back to the slides. Okay, in addition, I also wanted to, while I'm talking about permissions, we only have some basic permissions here for the tutorial project, but if you wanted to request for more permissions, on the top of this project, you would see this button called Request Permissions. You can click on this button. It'll take you to a form. On this form, we request that you fill this form describing the permissions you need, and a little bit of description why you need that permission and how you intend to use that. Once you submit your request, somebody from Fabric team would reach out and approve your request. On similar lines, for permissions, we also allow you to create persistent storage for your project, which can be attached to the VMs in your experiments. You can request that storage by clicking on this button, Request Storage. This also has a form associated with it. We recommend that you specify a brief description of your request and the need for it. Specify details about the volume you're requesting and the sites you're requesting this volume on. Again, on similar lines, once you submit your request, somebody from Fabric team would reach out and help you with this. Now that we've created a project, let's learn a little bit more. Who can create a project? I could create a project because I am a project lead. So anybody, project lead is an important role. Only a Fabric user who is a project lead can create projects. Who can be a project lead? Project lead is typically reserved for faculty or senior staff at educational or research institutions. You can request to be a project lead from the portal. Let's go back to the portal here. On the top right corner, you see your name. Click on it. You should then click on User Profile. It takes you to your profile page. As you can see, it lists the information about me here. And then under my profile, I have this tab called My Roles and Projects. I'm listed as a project lead, so you see a check mark here. But by default, when you log in, you wouldn't see this check mark. And there would be a button that shows up here which says Request to be project lead. So if you are trying to request to be project lead, we recommend that you click on that button, Request to be project lead. Another thing I want to highlight is project leads and project owners are responsible for the conduct of the experimenters they add to their project. Please familiarize yourself with acceptable use policy and the project lead policies available in Fabric knowledge base. So let me take you to this page. We have this page on the knowledge base which describes some different Fabric roles and project permissions. I would recommend that you read through this page to familiarize yourself with the policies and the various permissions available. Interacting with Fabric. You can interact with Fabric, like I earlier said, either with the REST APIs or using a Python library called Fablib, which is a wrapper on top of the REST APIs, which makes your experiments easier to run. Another thing to note is, unlike Genie, Fabric does not use SSL certificates. Instead, it uses short-lived API tokens that have a lifetime of 4 hours, but they can be refreshed. I will talk a little bit more about these tokens in a bit. And like I said earlier, we recommend that you use Jupyter notebooks, since they provide a way for you to create a reproducible, shareable experiment profile. You can build your topology, you can configure it, you can run your experiment, you can annotate and display plots. display plots and graphs, and then you can easily share your notebooks with other people and who can reproduce your results very easily. All this you can do from just the comfort of your browser. I'll also show a Jupyter example in a little bit. Another thing I want to highlight is that we have several list of tools. We have several tools coming up, which provide easier way to use Fabric. I would recommend for you to go to this article and find out more about these tools. Okay, let's talk a little bit more about sessions and tokens. Like I said before, Fabric does not use SSL certs. We use tokens. These tokens have by default, these tokens have a lifetime of 4 hours. These tokens are used both by the portal as well as the Jupyter Notebook. Under the hood, the user doesn't have to create them themselves, but the portal and Jupyter Notebooks are creating those portals for you. However, if there is a need for you to create the tokens yourself, you can go to the credential manager, Fabric Credential Manager, and create your tokens. Let's see how you can get to the Fabric Credential Manager. Again, click on Experiments. Under that, you would see Manage Tokens here. Click on Manage Tokens. You can go to the Fabric Credential Manager here. The Credential Manager lists all the projects you're part of. These tokens are project specific. Then you choose the project you want to create token for. For example, in this case, I chose Fabric Tutorials and click Create Token. Now the token has been created. I can either copy it or I can download the token. And all the created tokens for you are listed here. You can revoke them if you need to, if you have lost a token. By default, these tokens have a lifetime of 4 hours. We do allow for you to request long-lived tokens, but this is something we do not give by default. We would like to understand the need for you to have long-lived tokens. So if that is the case, we would go to the we would request for you to request request the access for the long-lived tokens from the portal. Again, you can do that from the user profile if needed. There's also a very informative Learn article which talks a little bit more about how the tokens are. I would recommend that you can go through this page and learn more about the tokens and reach out to us if you have any questions. Now that we've talked about the tokens, let's talk a little bit about how you will access your VMs. Once you're a member of a project, you can create slices, and then once you have created a slice, you would want to access your VMs. Fabric uses bastion hosts to safeguard access. What that means is you cannot log into your VM directly. You must go through the bastion host. You don't really log into the bastion host, you just use the bastion host as a hop to reach your VMs using the SSH commands. There are two kinds of SSH keys. That's why you have two kinds of SSH keys, bastion keys and the sliver keys. Bastion keys are managed through the portal and can expire every 6 months. Again, sliver keys can also be managed through the portal. They don't have to be. They also expire after 2 years. Fabric never keeps the private keys. If you lose a private key, you have to generate new key pair. You can have up to 10 key pairs of each type in the portal. Let's go back to the portal and see how you can create these keys. Again, let's click on the experiments. You have this tab called Manage SSH Keys. I already have created these keys for myself, but let's talk a little bit more about the bastion keys. You can specify a name here, example key, example bastion key, provide some description. and click generate. You can either do that. When you click generate, it will show you the generated key pair. We recommend that you download this because Fabric does not maintain your private key. I'm not going to save this because I already have a key pair generated. And again, if you already have a key pair which you want to use, you can just upload the public key, specify the description, and click upload. Like I said before, I did not download it, but the key got created, and it only saved the public key. On similar lines, you can create the sliver keys as well. From here, specify the name, specify the description, generate, or alternatively upload the public key, provide a description, and click upload. Once you have created the keys, I think now you're ready to see how to create an example slice on Jupyter Hub portal. Click on Jupyter Hub. This will take you to the Jupyter Hub. Click on sign in. Again, choose your institutional login. Once you log in, you'll see different container options. By default, the default container option is selected. We recommend that you use the default container option. Let's click start. Sign in with CI logon. This is how your view would look like when you log in to Jupyter Hub with the default container. Let's open the examples here. The examples have a start here notebook. We recommend that you open that notebook. Before you can do anything on Jupyter Hub, you need to configure your environment. So we are going to start with this notebook called configure environment. Like I already spoke about the keys, the bastion keys and the slice keys, this notebook creates all those keys for you, sets up the Jupyter Hub environment with all the configuration parameters, and then you're ready to create your topologies and run your experiments. While I was showing you the project, I was telling you, I showed you a specific field called project ID, which will come in handy. So this is the project, Fabric Tutorials. It shows your description, name, and then the project ID. This is something which is very useful because this is what determines the privileges you have. So when you run the configure notebook, you need to specify the project ID of which you are part of. In this case, since I'm running Fabric Tutorials project, by default it's already set up. I don't need to change anything, but when you as a new user run this notebook, you would have to replace it with the project you are part of. Let's run this cell. Let's run the next cell. It displays the config. You can then validate the configuration. The configuration has been generated. It says bastion keys do not exist or are expired. It generated the bastion keys, saved it for me. Let's save the config. Let me talk a little bit more about the configuration. So here it tells which Fablib version you are using. It also talks about the project ID, your ID of the project you're part of, where the log files are located. These are some of the parameters which we need, the Fabric API needs in order for everything to work. Token file is where the token file would be generated by Fablib by Jupyter Notebooks automatically. And again, like I talked before, Bastion host is what we use to access the VMs, and then location of your Bastion key and the slice key. It also generates SSH config file for you, and the Bastion username. I think I forgot to talk a little bit about the Bastion username. Let me go back and show you. When you create your Bastion keys, you would see this Bastion username. This gets automatically generated when you sign up. So that is what is shown here. All this information is needed for your notebooks to work. So let's go back to start here and create your first experiment. Run your first experiment. Hello Fabric. The first step here is to configure your environment, which we have already done. So we're going to skip this. Now we're going to import the FabLab library. Now we're going to list the available resources Fabric has. This API takes a little bit. It's an expensive operation because it's trying to gather all the resources available at this instance in time. You can also see the resources available on Fabric from the portal. I'm on the portal, click on this resources tab. You can see the entire map for Fabric here, and you can click on these blue dots to represent the sites. An orange dot indicates that that site is in partial maintenance. Some of the sites, if they are in full maintenance, they will be shown as red, but the sites which are active are shown in blue. For each site, you can see all this information: how many cores are available, how much disk, RAM, GPU, several things. The first number you see is how much is available, and the second number you see after the slash is how much is the total count. You can also see the same information down here, and then you can search for a specific site. For example, EduKY. This is typically a site which educators use for educational projects. Let's go back to the notebook. Again, similar information is shown here on the notebook. You can see this site, Clemson site, is BTP enabled. How many hosts does it have? How many CPUs or cores? What kind of components does it have? So all this information can be queried from the Jupyter notebooks as well. Let's run through next cell in this example. We're now creating an example. We are creating a slice with a single VM. Let's call this slice my slice and create this. Here we submitted the slice, and the slice is still configuring. We'll have to wait a little bit for the slice to come up. It takes a little while for the slice to come up. So for example, in this case, it took 142 seconds for the slice to come up. The slice is stable now, and the VM is active. Let's see if we can show the slice attributes here. Let's show the slice attributes. You can see a slice as by default, when a slice gets created, it has an expiration date of 24 hours, but you can extend your slice easily. There are several notebooks available, useful notebooks available from start here to do all of those things. Let's list all the nodes in your slice. So since we only had one VM gets listed here. And this cell is trying to SSH to the VM and echo this statement. So now that your slice is up, let's go back to the portal again a little bit. Click on experiments, projects and slices. And you can click on my slices. Your slice should show up here, and it's stable. Okay, if you click on your slice, you would be able to see your topology here. Like we created, it has only one VM here. So now we've done gone through the Hello Fabric example. Let me go back to the Start Here notebook. You can see here we have several examples available here. Like I was talking to you about having extending the lifetime of your slice. You can use this example notebook to extend the lifetime of your slice. And there are several other basic examples for networking, creating VMs, attaching network cards to them, passing traffic between your VMs. We have a bunch of examples for that, each representing different kind of network services, layer 3 services, layer 2 services. So we recommend that you explore several examples available here from the Start Here notebook. That's all. So that was all about how you can use Fabric. I hope that was helpful. If you run into any problems, we have several resources available for you to seek out help. Uh, we have our knowledge base accessible through this link, which contains all the documentation, APIs. It also has several user forums. So we have all the technical guides, information about how the API can be used. You can also go to the forums here and ask questions if you run into problems and you couldn't find a resolution for your problem. And like I already showed, from the portal, you can request to be a project lead, request for specific permissions you need, request for persistent storage. So how I did talk about how many sites we have. What is the network footprint of Fabric? Let's find out how big is Fabric's community as of today. We have close to 1,300 users, 200 active users every month. By active, I mean that every month at least we have seen 200 users with creating active slices, running their experiments. We have 107 international users. We have like several distinct organizations. Quite a few of them are educational organizations. We even have 42 international organizations. So far, we have 158 total projects, and at least 60 of them are doing few things. We collect metrics about which projects are doing experiments in a month, and use that information metrics to share this information with you. If you'd like to join the Fabric community, portal is the best way. I recommend that you go visit our portal, learn a little bit more about Fabric, and join our community, sign up, and start experimenting. You can also sign up to our newsletter. There's this link. We will also share this link at the end of this presentation. And we also have an ambassadors program. We also encourage you to create an account and encourage researchers to create an account. We are currently in the process of deploying a bunch of new resources, which will be available post the upcoming maintenance, which I already mentioned. The entire week, the testbed is not available. And there are several cool features coming up. I hope that you would sign up with Fabric and come explore Fabric and the new features. Okay. I think, Casey, I'm ready to pass on the baton to you.
Sure. Well, thank you, Kamal. This is wonderful. So now we'll head directly into the Q&A session. So our audiences has been typing their question into the Q&A box during your talk. So now we'll start to answer some of those questions. So let me see. I got one question here. The first one, how can I become a project lead?
Like I've already mentioned, that from the portal, when you go to the when you go to, portal, there is an tab called Experimenters tab. It will list you all the projects there. Um, on the top right corner, you have there'll be your initials would show up. You click that, your initials, you can view your user profile. And from your user profile, you can see what is your current role. By default, when you sign up with Fabric, you are just a user. You are not a project lead because we take that role really seriously. Not anybody can create a project. Um, there is a button there to request to be a project lead. Um, just click on that button and follow through the steps, and you are ready to go.
Sure. And for those of you that are students, remember you need to ask your professors to create a project as a project lead for you so that you can start using it. I see a second question coming in. Do I need to install any software to use Fabric?
No, you as a novice user, you don't need to install anything on your laptop or on your computer. You just sign up. You can start using our Jupyter Hub environment and run these experiments from Jupyter Hub. As you learn more about Fabric and Fabric's API, if you are interested in running remote experiments from your laptop, we do have the capability for you to install Fabric API and run experiments from your laptop and desktop.
That's great. Um, so the next question, does Fabric give a faster network?
It definitely does. The entire focus for Fabric is network. We do have several hundred gigabit links and 1.2 terabit links as well. But like like Spider-Man said, with great uh, cap okay, I'm forgetting the code, but it's not something that you can use Fabric to create experiments, run faster, use dedicated NICs like smart programmable NICs, which have the capability of 100 Gbps and 25 Gbps links, and run your experiments with a really high throughput.
Sure. And just to add on to that, I think for the students and researchers here, remember the faster network is not the only thing that Fabric offers. It's really how can you design something new and cool using that fast network with a lot of the programmable features that will encourage you to take a look at. We have one more question coming in. Are there examples for advanced features available on Fabric?
Yes, there are several examples. Like I was showing you on the start here, it's really populated there. We have examples from very basic um, usage of Fabric. As a novice user, you would want to know how to spawn VMs, connect them. We have examples ranging from that to examples such as how would you program your FPGA card? How would you run your P4 program? We also have example for using DPTK with the SmartNICs, ConnectX-5 and the ConnectX-6. So we have a wide variety of examples available. And if you don't find something you're looking for, feel free to reach out to us. We would love to work with you and work on creating more examples and be helpful.
Absolutely. So as Kamal showed earlier, the Start Here Jupyter Notebook that you will find when you first get into Fabric, it has a long list of advanced, very cool features. So feel free to explore and get started on something cool. One more question. Can my experiment connect to the internet?
Yes, but if you're running an experiment which only lives within Fabric, you can connect to all your resources within Fabric easily. You don't need internet for it. But yes, you can download you can, if your experiment is ingesting data from the internet, you can upload data as well to your Fabric experiment. We also have specific network services such as FabNet EXT services, which allow you to give your experiment internet access. But this is a service which is opening your experiment to the entire world. So we do not take that lightly. We really want to know the need for you to have such a service. So you can request permission for that kind of service. We can discuss with you and help you use that service in an efficient way without jeopardizing the security of the testbed.
Sure. And one more question. If I do security research, are there rules of what I cannot do?
If you are running your experiment within Fabric, you're covered. We let you as I said before, it is a sandbox. You can do anything within that sandbox. That is the reason why Fabric exists. Um, but if you're doing Bitcoin mining, uh, we also have tools watching all those things happening. If we find out anything like that, we would probably shut down your experiment.
Sure. And one last question we found here. Can you speak to the intention of the workshop in September? What would you expect us to learn at it?
We have several new features coming in. We have several users bringing in their experiments, showcasing their work, how they are showing using Fabric. We have several P4. We have several users who are trying to use P4 FPGA cards, and we are also working with other users who are trying to use the P4 programmable Tofino switches. So that's one of the key areas we are looking to let everybody know how Fabric is helping those experimenters do that. And I'm sure there'll be several others as well. Uh, that's what I had
Sure.
on top of my mind.
And I can probably share some more information about the workshop. Every year, Fabric runs a number of workshops throughout the year, and the real intention is to invite you to connect with other researchers using Fabric. Every time we always have multiple very new, exciting experiments that will be showcased. And also, depending on each workshop, we often collaborate with other workshops. So this time, the September workshop will be collaborating with multiple NSF research test beds. So you will learn not just about Fabric, but a lot of the other test beds that are interconnecting with Fabric. And so how can you design your research across multiple of them? So you're welcome to go to the website and the link from the email to find out more about the September workshop once the more information is shared on the agenda. Okay. So I think that's all the question we have today, and that's a very exciting, engaging conversation. So I'll just say that thanks again to our speaker, Kamal, today. That's really informative. And in so there here you will see there's a lot of resources that are being shared right here. Um, so make sure that you connect with us. There, if you haven't gotten the Fabric newsletter, here you can see the newsletter link. And there's also a link for signing up Fabric office hours. If you're using Fabric and you come to any questions that you're looking for answers and you cannot find answers on the Fabric forum, you're welcome to sign up for the office hour and speak with us directly. Or if you want to run some cool experiments and you don't know what's the best way to do that, you're welcome to let us know and then we can help you get going. A lot of other resources provided here. The Fabric Testbed link. We have a YouTube channel. One thing is called the Fabric Matrix. We highly recommend every researcher to fill out one of the Fabric Matrix. It talks about what your research purposes are and then the most important experimental goals you have that help us make sure Fabric fits your need better. And it also gives us an opportunity to showcase, promote your work. So if there are some exciting new research you're doing, you want us to discuss with you, please feel free to contact us. We're also running an ambassador program. This is for professors, researchers that you're in an interesting, unique research domains. You feel like you are one of the early users using Fabric, and then you wanted to work with the Fabric team to help your colleagues in your area to do more. please contact us. We'll love to see whether the ambassador program can help you, provide you with the right resources to stimulate more research using Fabric. And then finally, if you're on LinkedIn, we have a LinkedIn page. And we do encourage you when you're using Fabric for your research, please feel free to cite us. There is a link that you can find on this link where you can make it easy for you to cite it when you publish your work. And finally, if you haven't gotten from today, you are welcome. You're encouraged to sign up Fabric account right away. So you can go to the portal, portal.fabrictestbed.net, and you can get started there. Next slide. So in addition to Komal, our presenter today, we want to also acknowledge that this wonderful webinar is not possible without a big team working behind it. And then I want to extend our thanks to two core facilitators for the Fabric webinars, Chelsea Davis, our project manager for Fabric, and Jayshree Jagannatha, our social media specialist. They spend a lot of hours to design these webinars and make sure these topics are best fitting the researchers' needs. Thank you. And again, thanks to the audience for all your participation. So in addition to the recording that we're going to share with you, the slide deck, and then the link to our Slack channel, all that will be provided to you after this webinar. We also will hope you will reach out to us for more questions. We do want to encourage you to attend upcoming webinars or share this with your colleagues. So in August, we have two more exciting webinars coming up. August 19 at 2 p.m. Eastern Time, we're going to have the Stitching Together Innovation with Fabric Users webinar. This will be featuring research scientists at Argonne National Lab, talking about some cool research experiments that they're doing. And August 20 at 3 p.m. Eastern Time, we'll have another Mastering Fabric Tips and Tricks webinar led by Paul Roof to show you more of the advanced features with Fabric. So with that, thanks. And then make sure you visit our YouTube channel, right, listed right here. And finally, very happy to have everyone today. I hope you have learned how to get started with Fabric, but most importantly, know how to reach us so that we can help you get your research started. Thanks, everyone.